Okay, we're here in Waukesha, and Alan Weinkauf used to work with the GM division of aeronautics, or what was that? The
Delco Electronics.
Delco Electronics. And he worked on the Apollo program. He's going to give us a little of what he did in his job there. Go ahead.
Okay, well, I was a manufacturing engineer and really had nothing to do with the design aspects of the Apollo guidance system. The Apollo system was put out when it was designed by MIT, Draper Laboratories at MIT, and we were the successful bidder on building that in our plant in Oak Creek, Wisconsin. The system was a gimbaled system in that every guidance system, including aircraft, of course, the functions that you're trying to control are roll, this motion, pitch, which is this motion, or yaw, which is this motion. So the system was gimbaled, and there was one gimbal that controlled each one of those functions. Each gimbal had one gyroscope, which of course sensed whatever direction the thing was moving in, and the accelerometers, of course, determined the speed at which it was traveling.
Each gimbal's on a bearing?
Each gimbal was attached to a stable platform, and the stable platform we calibrated in our plant so that it was zeroed in on the North Star. So all of the motions then of the system sensed what deviations there were from the North Star. The engineers that designed the flight patterns and so forth, and they use a system of mathematics called Boolean algebra, and most of that was done actually in Houston at the NASA Center. The system had a computer, and it was a rotary drum computer, a magnetic plated rotary drum, and it had read-write heads on it so that as the signals came from the gyroscopes or the accelerometers, the heads dropped or picked up and sent the signals then to determine which direction it was going, or what pitch it was in, or which roll it was in. It was all pre-programmed when it took off, and so it was pre-programmed with the starting point, of course, down at Cape Canaveral, down in Florida, and of course the destination, or the end point, was the moon. So as it took off, and many of you have seen the rocket blast off from Cape Canaveral. Now there were actually two systems on board. One, of course, controlled the flight vehicle, that is the rocket that took them up to the moon, and the other one, of course, was in the lunar excursion module. That's where the two men were in that actually landed on the moon. The reason for that, of course, was that as the lunar excursion module was on the moon, the mothership, if you will, was going around the moon, and when they got ready to take off, the two systems had to talk to one another because the excursion module blasted off from the moon and had to meet up with the mothership, which was circling, so that the navigation system had to be very precise. The computer system actually took over from that point on and directed the plane, the Apollo, back to the Earth. That, of course, is very precision also, because that thing is traveling at greater than the speed of sound, and the re-entry had to control the re-entry, and it had to fire the retro rockets at just the right time so that it would come down at the place that it was intended to come down. Now, the Apollo system, of course, those pilots, those crew members landed in the ocean. They didn't land at Cape Canaveral like the current systems do. So once it got down into the Earth's atmosphere, a parachute deployed, and it floated down, and out in that area there, they would have a flotilla of boats so that they could be picked up very quickly from that event. By today's standards, that whole navigation system would be absolutely obsolete. It had several boxes of electronics. All of the modules that were in there, the small electronic modules, were welded components, and And the computer, of course, was a big box with a rotary drum in it that totally archaic. They wouldn't use that today anymore. And the gyroscopes back in those days were floated and had ball bearings in them. That's obsolete anymore. Today they use laser gyros, and I don't know what they use for an accelerometer, but it's long gone. We were very thrilled, of course, to be associated with that program, and I personally, along with a lot of our other employees, had a lot of opportunities to meet with some of the astronauts that actually flew in those flights that they had. One of the most thrilling ones, of course, was Apollo 13. Most people have seen that movie. When the unit, the vehicle, was on the way to the moon, an oxygen tank blew the side of the vehicle out, and of course they could not now continue to the moon. So very quickly, the engineers that were calculating flight programs and so forth had to recalculate all of the re-entry programs so that they could come down. Unfortunately, they couldn't bring them down where the flotilla was waiting, so they had to bring them down somewhere else. And say they picked out an aircraft carrier in the Pacific Ocean. Now you think an aircraft carrier is a huge, huge target, but in the middle of the ocean it's like a blip. And back in those days we didn't have radios in the plant, but that day they let us bring them in. And so once the pilot of the re-entry vehicle pushes the button, he's hands off. The computers take over and do everything. And I can still remember sitting on the edge of my desk, as we all were, as that thing came back into the atmosphere. And of course, as it's entering the atmosphere, there is so much electrostatic noise made that you can't do any verbal communication.
20 seconds. 20 seconds.
At any rate, it was a thrill because the first message that we heard over the radio was, "We have them in sight," which seemed like a miracle that they could bring that thing from halfway to the moon back
2
down
seconds.
and landed it within sight of an aircraft.